everybody. Today we're in the second section of Unit 1 and we're going to talk about dot plots and stem and leaf plots. So first we're going to talk about dot plots, and in a dot plot each data entry is plotted using a point that lies above a horizontal axis. A dot plot allows us to analyze how that data is distributed, which also called the shape, either skew left, skew right, or no skew. It also helps us determine specific data entries, and it shows us possible outliers because unusual data is going to stand out and we're going to be able to see it. So in this first set of data, it's a company with 278 employees, and they were concerned that there was a problem with their employees showing up late to work. So management recorded how many minutes each person was late. If they showed up early or on time, no information was collected for that employee. So we only see the employees that are late to work. I'm going to zoom in so we can see this a little better. Still working on how to not get this to tilt whenever I zoom in, but unsuccessfully. Maybe I'll get better. So here we go. We can see that really good. So here I can see this horizontal axis, and I've titled it minutes late to work. So the way that a construction of a dot plot would occur was I would count, well, how many people were 1 minute late to work? It looks like I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would have unit 1, and I'd have 12 dots. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I would say, all right, how many people were 2 minutes late to work? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'd have 16 dots above the 2. And I would want to keep them as lined up as possible, because that way you're going to be able to see exactly how they compare. So since I line these up, that's 12, 13, 14, 15, 16. And then I'm going to write etc. because I don't want to go on and continue doing this because it would take up a lot of time, and I think you guys get the idea of how this is going to work. So let me switch to the next slide. Here I have this late to work dot plot for you. You can see, oh, I don't want that there. You can see now you've got all the dots that represent all of the people that were 1 minute late to work, and 2 minutes late to work, and 3 minutes late to work. Let's take a look at this column right here. What does it represent? Well, we can see we've got 4 dots, so that means 4 employees were 15 minutes late to work on this particular day that they were counting those up. Next, let's define the range. So the range of any univariate data set is going to be the max data entry minus the minimum data entry. So here I can see my max data entry is a 26, and my min data entry is a 1. Notice it doesn't matter how many dots I have there. The max data entry is a 26, the minimum data entry is a 1, therefore my range is 25. And then next, the mode of the data set is the data entry that occurs most often. Mode is most often. So with a dot plot, it's really easy to see because I can just search for what is the highest bar, and that would be 2. So therefore, the mode of this data set is 2 minutes late to work. I'm going to draw a line kind of over the top. It looks like that data, we're going to say, is skewed to the right. That's how I'm going to say that. Sometimes a little trick is to follow the tail. Like wherever the tail is, that's what your skew is going to look like. Shape is really important when I'm looking at data distributions. It kind of tells me the flow of the data and where most of the data is located. So what I like to do whenever I'm looking at shape is you've got your dot plot, and you've got dots somewhere. If you draw a line over the top of the data and it looks like this, we'd say this is skew left. Likewise, here's your horizontal axis, and you were to see something like this, we would say that's skew right. How would we describe the shape of our data? I'm going to go back. So I would say our data is skewed to the right for our late to work data. So this is what I mean by follow the tail. Follow the tail, skew left. Here's the tail on this, skew right. Next, we're going to talk about stem and leaf diagrams. So here I have a list of scores, and I don't know what they're on. Let's say a quiz. These are quiz scores. You have a legend here that tells you how to read this as like a map. So we would say 4 bar 7 is equal to a score of 47. 5 bar 7 would be 57. So you can see here that all of these are my stems and these are my leaves. Hence how it gets its name as stem and leaf plot. It doesn't always have to be this way, but it is really helpful if you order your stem and leaf plot, specifically in ascending order. Ascending order is going to be really helpful. A note about your stems is it's really nice if they are just 1 digit. Oops, wrong way. I meant leaves is 1 digit. My bad. Stems, I don't care how many digits they are, but the leaves, they need to be 1 digit. That way, whenever you're reading them, you know that that's the last number in the set. So let's take a look at this example down here, this data set. So it says the following numbers are text messages sent last week by the cell phone users of the junior class at Porter-Gaud School. And I want to construct a stem and leaf diagram for this data set. So the first thing I have to do is I have to figure out what I'm going to use for my stems and what I'm going to use for my leaves. And I'm going to zoom in because I really don't need anything other than these numbers. So I usually try and look for the minimum and the maximum in the data. So I see a 92. That might be the min. Let's see if I can see any smaller number. I think that's it. So 92. And then let's look for the maximum number. It looks like I can see a 144. That's the highest I see right now. Oh no, 163. There it is. So for the leaves, I need to go, it looks like if my leaves can only be 1 digit, if I were to cut these off, I need my stems to go from 9 to 16. So I'm going to set those up. So 9, 10, 11, 12, 13, 14, 15, and 16. I'll draw my bar. So I'll try and get these in ascending order as I go, but I might have to tweak it close to the end. So first, let's find all of my 9s. I got a 92, a 96, a 98. Do I see any others? I think that's it. So it looks like I just need a 2, a 6, and an 8. Now let's look for everything in the 100s. 104, 109. Probably just go row by row or column by column. 107. Let's see. 107. Another 107. And a 105. So now I'm going to try and get these in ascending order. So I've got a 4. I've got a 5. I've got 2 7s. And then an 8 and a 9. It's going to be really important as I write this stem and leaf plot that I try and keep everything lined up as I go. All right, so let's look for what I need in the 111s. Here we go. 118. I should say 110s, not 111s. 117, 116, 112, 118, 119. This might be a big one. 112. Let's see. 119, 114. 113. Okay. So yeah, this is going to be a pretty big one. It looks like 112 is my smallest. Then I have a 113. Oh, I had 2 112s. So I need to get rid of this. I need to get another 2 here. Then grab my 113. See, I have 114. And then I have a 116, 117, 118, and a 119. Oh, I had 2 118s. And then I have two 119s, so I need a 9 and a 9. All right, so that just barely fit. All right, so let's move on to the 120s. So I've got a 126. Let's see, 123, 122, 129, 122, 126, 121, 128. So again, it's another long one. So let's see, what's the smallest I've got? I've got a 121, and I've got a 122 two times, and then a 123. Next, it looks like 126, and I've got two of them. Next, I've got a 128, and then a 129. Excellent. And so I'm just going to keep going in this fashion. Hopefully I'm almost done. Hopefully these aren't going to be too much longer. Let's look at the 130s. Got a 136, another 136, a 130, a 139, a 133. So the smallest number that I see there is that 130. So I'm just going to put a 0 as my leaf. And then I've got a 133. And then I've got two 130. Nope, there's one 136. Thought I had another one. I do. 136 right here. And then my 139. Now I'm done with that one. Let's look at the 140s. I got a 145, 145, 148, 144, 140, 143, 146. This is a big one. Again, 142. I see my list is starting to get a little jumbled, hard to see. All right, so I'm going to grab that 142, then that 143. Then the next is going to be the 144 right here. One of those. And then I've got two 145s, 145 and a 145. Then I got a 146. Did I have two 140s? Did I not cross this out? Hopefully I just missed that 140 right there, which means I got to shove all of these up. Okay, so I'm going to make this list. It should be a 0, 2, 3, 4, 5, 5, 6. This is the hardest part about a stem and leaf plot whenever you're organizing your data and you're trying to put it in ascending order as you go. So I missed that 140. I got to go back and add it back in. There we go. So now I'm back at that 146. And let's see, I have a 148 right here. And hopefully that's it. So I'm going to go through and I'm going to just really cross out the stuff that I've used. Looks like I've used all of this. Oh, not the 163. I can see that really good. Then I've used all of these. Use this. I've used all of these. Okay. So now I can see what I'm working with, and it doesn't look like I've got too much to go. So I need my 150s, and I've got a 152, 155, 159, and then my 160s, and I got a 163 and a 160, so 0 and a 3. All right, there. I think that does it. So now I have this stem and leaf plot that represents the number of text messages that cell phone users at Porter Gaud sent last week, and I just need a key. I'm going to do 9 bar 2 equals 92 text messages. Oh, I have a little key there. Okay, so this is a pretty neat thing about stem and leaf diagrams. If you rotate a stem and leaf diagram 90 degrees counterclockwise, you can see that a histogram-like shape is created. And we're going to learn about histograms in a future lesson. But what a histogram does is it won't give you exact data points, but it gives you how many sit in a certain range. And so you can see I took those scores and I rotated it 90 degrees counterclockwise. So you can see in the 40s, you would see it's 1 unit high because there was 1 score in the 40s, 1 score in the 50s, 3 in the 60s, 5 in the 70s, and so forth. So this would be called a histogram. We're going to talk more specifics about that. Something else that's nice about it is as long as you've got everything in ascending order, well, the stems at least, you can draw this and see the shape is skewed to the left. You can see your tails here, meaning most of the data is sitting to the right. And what I've got here for you is I've got this histogram that I generated using our Fathom data of these scores, so you can see that histogram's shape. So that is, I believe, the lesson for dot plots and stem and leaf plots, and you guys are all set to do the problem set for lesson 1.2.